Okay, in this segment, we're going to look at an application of graphs to a classic recreational math problem. And what we want to show is the following. So it turns out that if you take any gathering of 6 people, then either 3 of them will all know each other, or we'll be able to find 3 of them who don't know each other at all. None of the people in that second group of 3 knows either of the other 2 people. And we can use graph theory to analyze this situation and show that this is in fact true. And this is going to be a lot easier to work with than trying to reason through this problem without the use of graphs. So how can we use graph theory to approach this? Well, we've talked about the idea of we can use graphs to represent objects in a problem, and in particular to use edges to represent relationships. And so what we're going to do is we're going to construct a graph with vertices for the 6 people. And we're going to draw edges in blue if they know each other, and edges in red if they don't. So this is a sort of graph edge coloring problem. We're going to draw a graph, we're going to color the edges, and we want to find our goal is to show that in this graph, there must be either a red triangle or a blue triangle. Right? A blue triangle corresponds to finding 3 people who all mutually know each other, right? Because blue edges correspond to 2 people who know each other. And a red triangle corresponds to 3 people who all don't know anyone else in the group, right? Because red edges correspond to 2 people not knowing each other. Okay, so how can we reason through this? Well, we've got a gathering of 6 people. So I'm going to go ahead and draw a graph with 6 vertices, and we'll start filling in the edges in a bit. So I've got 6 people here. And I want to think about person number 1. There are 5 other people at the party, and so there have to be at least 3 people that either person number 1 knows or that person number 1 doesn't know. If you think about it, we start trying to go through and try to distribute things as evenly as possible to avoid both of those happening. If we say, okay, we know person number 2, and then we don't know person number 3, and then we do know person number 4, and then we don't know person number 5. Now, no matter what color I make the last edge, we'll have 3 of the same color. So let's say that we do know person number 6. So 1 either knows at least 3 people, or does not. And so we're going to analyze this first case. In the other case, we would just swap all the reds and the blues, and the pictures will look very much the same. Okay, now, how could we easily get blue triangles in this graph? Let me label some more vertices here. Let's give them all their numbers. So if number 2 and number 6 know each other, then we immediately get a blue triangle. The same thing for number 2 and number 4 and number 4 and number 6. Put these in as dashed lines. So if any of these dashed edges are blue, then we're done. Right? Then we will have identified 3 people who all know each other. So let's say we want to make sure this doesn't happen. We're trying to show that we're trying to find a counterexample. We want to find a picture of 6 people in this graph where there are no blue triangles and no red triangles. So what I'm going to do is I'm going to assume, well, the opposite. But if 2 and 6 don't know each other, I've got a red line there. Okay. Well, we said if 2 and 4 know each other, we would be done. So we also have to put a red line there. And then the same thing, 4 and 6 have to not know each other. And then we're done. But wait, I've drawn a red triangle. If none of these pairs know each other, we have a red triangle. Two, 4, and 6 are a set of people who are mutual strangers. And graph theory helps us with this problem because it lets us look at this picture of our graph here and coloring our graph in a way that makes the chain of logic that we followed in words here easier to understand. And many applications of graph theory fall into this same sort of category. And we've seen some like this in this class. Your bonus problem for your final homework assignment is to analyze a similar situation in which there are only 5 people at the party and try to find a setup like this where there in fact are no 3 people who are all mutual acquaintances or 3 people who are all mutual strangers. And we will stop there.